Today we're going to be checking out inverse trig functions. We used to go from angle to coordinate. Now we're going from coordinate to angle. Let's see what this means. So let's take a look back at sine theta on the unit circle. So on the unit circle, there's a blank one here. We have angles of 0, and we have a big piece which gives us 30, little piece 45, add another 15 for a little piece 60, and then 30 for a big piece 90. And these angles give you certain coordinates on the unit circle. So we have 1, 0 at 0, and we have 0, 1 at 90, because those are the quadrantal angles. And the radius of the unit circle is 1. So these are the coordinates. At 60 degrees, we have coordinates of 1/2 and √3/2. At 45 degrees, they're both √2/2. And at 30 degrees, we have √3/2 and 1/2. Now keep in mind, specifically for sine is the y coordinate. So sine of 0 is 0, sine of 30 is 1/2, sine of 45 is √2/2, sine of 60 is √3/2, and sine of 90 is 1. Now what we're going to do is reverse this when we do arcsine. Sine to the -1 of y is theta, and it's also known as arcsine. Okay? The reason I put y there is because we want to focus on the y coordinate. So we're going to look for those outputs on the unit circle between -90 and 90 degrees. The result of taking arcsine of a number will be an angle. So that's why I put equals theta. Common numbers that yield exact values for arcsine are going to include 0, 1/2, √2/2, √3/2, and 1, which are the same values that you saw me highlight on the unit circle about a minute ago. We're also going to deal with these negative numbers, and you'll notice that I'm using the exact same numbers: -1/2, -√2/2, -√3/2, and -1. Let's see how this fits on the unit circle. So here are the ones that we already went through. If we go down the unit, you'll see that if we go in the clockwise direction, we can now get negative angles. So we're not using the classic unit circle where we have 270, 300, 315, and 330. Instead, we're going to go down the circle to -30, which will give me √3/2 and -1/2. -45, which will give me √2/2 and -√2/2. And -60, which will give me 1/2 and -√3/2. And we're also going to go down to -90, which gives me 0, -1. Now again, we are focused on the y value. So all of my negative inputs for arcsine are going to give me negative angles. Okay, this will change when we do cosine. For sine and when we do tan, we're going to use negative angles. Okay, so let me give you an example. If I have sine to the -1, or arcsine of √3/2, I'm going to go to √3/2 as a y coordinate on the unit circle, and I'm going to get the angle. So that is going to be equal to 60 degrees. Now if I happen to get a negative input, so if I do arcsine of -√3/2, I'm going to instead go down to the bottom of the unit circle where I have my negative coordinate, and my answer will be -60. So it's the exact same answer except negative. And by having this unit circle filled out, you basically have a cheat sheet as to what arcsine of those common values are. Anything outside of these common values you can go ahead and use a calculator. Now let's take a look at cosine. Now you'll notice I changed that y to an x there. That's because cosine is the x coordinate on the unit circle. And the output for this arc cosine will be an angle as well. So this is also known as arc cosine. For outputs on the unit circle, the x coordinates. But instead of going from -90 to 90, we are going from 0 to 180. And I'll explain that in a second. The result of taking arc cosine of a number will be an angle. The common numbers that yield exact values for arc cosine are going to include those same values that you saw for sine. 0, 1/2, √2/2, √3/2, 1, and then the same numbers but negative, -1/2, -√2/2, -√3/2, and -1. Now if you look at what we had for sine, you'll notice that as far as x coordinates go, these are all positive. And so I don't have anything to use for my negative inputs. All right, so we're going to shift this over to include angles from 0 to 180. Now as we go from 90 to 180, what you're going to notice is we have a negative x coordinate. So arc cosine of -1/2 will be 120. So you notice there's not a negative output for cosine. Arc cosine of -√2/2 will be 135. Arc cosine of -√3/2 will be 150. And arc cosine of -1 will be 180. So let's use the same example again. If I was to take arc cosine of √3/2, I would look for √3/2 as an x coordinate and get the matching angle, which would be 30 degrees. If I was to get arc cosine of -√3/2, this is not like sine where I can just put -30. I will find it over here with 150 degrees. So my answer is going to be a positive 150. All right. And cosine is unique like that. The next one that we're going to be doing is tan, and we're going to use the same unit circle that we used for sine. So here we have arctan of a number equals theta. So the tan to the -1 is also known as arctan. You look for outputs on the unit circle between -90 and 90 degrees. And the result of taking arctan of a number will be an angle. So the common numbers that yield exact values for arctan are a little bit different from sine and cosine. We're going to be dealing with numbers like 0, √3, 1, √3/3, and -√3, -1, and -√3/3. So here's our unit circle, and we have to do a little bit of math work to get the tan of all of these angles. You can't just look at the unit circle and get these values. Of course you can if you write them down on your personal unit circle. So tan theta is y over x. All right. So for example, if I'm going to do tan 30, I'm going to look at the y coordinate, 1/2, and divide it by the x coordinate, √3/2. Of course, both have a denominator of 2, so the 2's will cancel, and I will end up with 1/√3. Now let's remember, we don't want to keep that radical at the bottom, so we're going to multiply the top and the bottom by √3 to simplify this, and we end up with √3/3. So tan 30 is root 3 over 3. So I'm going to put that over there in red. So I'm going to go ahead and fill out the rest of these tans. So just, you can try to get them on your own and make sure that you're doing it the right way. For 45 degrees, we have 1. For 60 degrees, we have root 3. At 0 degrees, we get 0 over 1, which is 0. And at 90 degrees, we get undefined because we're dividing by 0. Y over x would be 1 divided by 0, which is undefined. Now, as we go to the negative side, you're going to get the same exact answers, but with a negative sign in front. So at negative 30, we have negative root 3 over 3. At negative 45, negative 1. At negative 60, negative root 3. And at negative 90, it is still undefined. So let's do a quick example. Let's say I needed to find arctan of root 3 over 3. Well, I'd look for root 3 over 3 after I've taken these notes and worked all of these out. Root 3 over 3 is what I get if I take the tan of 30. So my answer is 30. And if I do the same thing for negative root 3 over 3, I will get the same answer except negative. Alright, so stay tuned for the next video, which will have some worked out examples. Have a great day.